This lesson is called Factoring Using Multiple Strategies. And the idea here is that we've spent the past few lessons learning a bunch of different strategies for factoring. We started with common factoring. We looked at common factoring out of binomial. We looked at two ways of factoring trinomials. One of them using when the value of a was 1, and the AC method that we use when the value of a was not 1. We looked at difference of squares. So this section is just going to give you some practice deciding which of these types of factoring you're going to do in any given question. And there'll be the odd question where you need to do maybe 2 of these types of factoring. So to kind of organize your thought process when you encounter something that you may need to factor, I've put together this little kind of checklist here. The first thing on the checklist you should always check is there a factor that is common to all of these terms? Always check to see if there's a common factor first. Okay, if there is, you want to factor that out using those techniques of common factoring that we talked about. Now, sometimes what happens is after you have done your common factoring, you might have something that can still be factored. So then you want to still check to see if after having common factored it, you can still do any of these other types. Okay. Now, if what you have has 2 terms in it, you could check to see if this is a difference of squares, if both of the terms are perfect squares. Then, after you factored it as a difference of squares, you'd be done factoring. If the thing that you have has 4 terms in it, you could try to factor by grouping. If you're able to factor it by grouping, then you'd be done. If the thing that you have has 3 terms in it, then you know it's a trinomial and you're going to try to factor it using one of these 2 strategies. If a is equal to 1, remember we're looking for 2 numbers that multiply to the last number, add to the middle number, and then we put those 2 numbers into the brackets, and then we're done. If a is not equal to 1, it's a little bit trickier. We have to look for 2 numbers that multiply to AC, add up to that middle number. We use those numbers to break up that middle term, and then we factor by grouping, and then we're done. So we'll go through some examples here where the idea here is just we're going to see what types of factoring we have to do in each one of these expressions. So our first one here, 12x squared minus 27. The first thing we're always going to check for is there something that can be common factored out of both of these terms? There isn't a variable that is common to both terms, but 12 and 27 are both divisible by 3, so we can common factor out a 3. This will become 3 times 4x squared minus 9. Once we've done our common factoring, we're not done with the question. We want to look at this thing that we have here and ask ourselves, can we factor this anymore? And this is something, because it has 2 terms, which could possibly be a difference of squares. Let's look at this. That 4x squared is 2x all squared. The 9 is 3 all squared. So certainly this is a difference of squares. So if I factor that as a difference of squares, it'll be 2x minus 3, 2x plus 3. This 3 that we factored out earlier is still there. So this would be our fully factored form, okay, because we've got this written as something times something times something else. That's as factored as we can get it. All right, let's look at our second example here. X squared plus 10x plus 10xy minus 20y. First, we're going to check to see if there's a common factor. Is there something that is common to all 4 of these terms? And yes, they're all divisible by 5. So I'm going to factor out a 5 here, and I'll be left with x squared minus 2x plus 2xy minus 4y. Now I look at the thing that's in the brackets there, and I have to ask myself, can that be factored? Well, there are 4 terms there. If there are 4 terms, that suggests we want to maybe try factoring by grouping. So I'm going to group these 2 terms together, and I'm going to group these 2 terms together. This 5 that I factored out, it's still going to be out front. So I'm just going to change to square brackets there. And then I'm going to look at the x squared minus 2x. What can I factor from there? I can factor an x as common. I'll be left with an x minus 2. And then from our next 2 terms, let's see, a 2 is common and a y is common. So I'll have x minus 2. We finish off our factor by grouping by noticing that the x minus 2, sorry, is common to both of those, so we're going to factor that out front, and then we'll be left with x plus 2y. And there we are. It's fully factored. We've got it as something times something times something else. All right. Our next one here, we've got 2x squared plus 10x plus 12. First thing we're going to do is check to see if there is a common factor. There isn't a variable common to all of these terms, but all of the numbers are divisible by 2. So our first step is going to be common factor out that 2. 2x squared, we're going to need a 5x here to get the 10x, and then a 6. All right, now let's look at this thing in the brackets here and think about whether or not we can factor that trinomial. We can, and this is a trinomial that has our a value would be equal to 1 because there's no exponent on the x squared now that we factored that out. So we are looking for two numbers that multiply to give us positive 6 and add to give us positive 5. Those two numbers are going to be 2 and 3. So we know that our factoring, we've got the 2 still. We're going to have our two brackets here. We know that we need an x and an x to get our x squared here. And the other two numbers are going to be positive 2 and positive 3. So our final factored form here is 2 times x squared plus 2 times x squared plus 3. Our next example here, 3x squared plus 8x minus 3. First thing we're going to check, is there a common factor? And no, there's not a common factor. So there's nothing to do here except try to factor this trinomial. Now, this is a trinomial with an a value, which is 3. So because a is not equal to 1, we're going to have to use the AC method. So a times c, c is negative 3. So 3 times negative 3, a times c is going to be negative 9. So we are looking for two numbers here that multiply to negative 9 and add to that middle term, positive 8. Those numbers are going to be, let's see, positive 9 and negative 1. Multiply to negative 9, add to positive 8. What are we going to do with those two numbers? We are going to use them to break up our middle term. So our first term stays the same. We're going to have a plus 9x minus a 1x minus 3. And then we're going to factor by grouping. We're going to group these terms and these terms. From our first two terms, we can factor out a 3 and an x, common factoring. Let's see, that's going to be x plus 3. Will get us the 9x. And from our second terms, well, we know in factoring by grouping that we want to end up with a binomial term that's common. So we hope that we can do some factoring that is going to get us an x plus 3 here. I've got negative 1x minus 3. The thing that we can factor out of here is a negative 1. Negative 1 times x will give me negative 1x. Negative 1 times 3 will give me the negative 3. Now I can common factor out this x plus 3 term that is common. So x plus 3. And I'm left with all of this stuff, 3x minus 1, that I haven't already factored out. So there is our factored form. All right. 8x squared minus 22x plus 12. Step 1. Can we common factor this? Let's see. There is going to be a 2 that is common to all of these terms. And that's the biggest thing I can factor out. So let's factor out 2. 4x squared minus 11x plus 6. Now I'm going to try to factor this trinomial that I have left over. My trinomial has an a value of 4. So I got to look at the c value of 6, and I know that AC is going to be 24. So I'm looking for two numbers that multiply to positive 24 and they add to negative 11. What might those two numbers be? They are going to have to be negative 3 and negative 8. Negative 3 times negative 8 is positive 24, and we add them up, and we get negative 11. So I still have this 2 that I factored out front. I am going to use my negative 3 and my negative 8 to break up that middle term. 4x squared minus 3x minus 8x plus 6. And then I'm going to factor by grouping inside those brackets. So from my first two terms, I can factor out an x, 4x minus 3. And from my second two terms, I can factor out, well, let's see, I can factor out a 2, but I'm actually going to factor out a negative 2 here, because that's going to give me 4x minus 3, which is what I want, because now that 4x minus 3 is common. And I'm left with the x minus 2 inside the brackets. Okay, so we'll take a look at our next one here. 3x cubed minus 10x squared plus 8x. Always check to see if we can common factor it first. So is there something that is common to all three of these terms? Yes, they all have an x in them. So let's factor that x out. 3x squared minus 10x plus 8. When we do that, we are left with something that we can factor as a trinomial. 3x squared minus 10x plus 8. Our a is 3, our c is 8, so we're looking for two numbers that multiply to AC, which is positive 24, and add to negative 10. Those two numbers are going to be negative 4 and negative 6. So we still have the x out front. We're going to use that negative 4 and that negative 6 to break up the middle term. Negative 4x minus 6x plus 8. And then we are going to factor by grouping inside here these two terms and these two terms. So what is common between 3x squared and negative 4x? Well, the x is common, 3x minus 4. And in my last two terms, I'm going to factor out a negative 2. Because that's going to give me 3x minus 4, exactly like I wanted. So we still have the x out front. We can factor out the 3x minus 4, and we're left with the x minus 2. So there we have it in our final factored form. Okay, it's written as something times something times something else. Our last two examples here. 5x squared minus 25. This looks like it might be a difference of squares, but we should always common factor first. So I'm going to factor out a 5, which is common to both the 5 and the 25. X squared minus 5. And now, is the thing in the brackets a difference of squares? No, it is not, because although the x is like x squared, the 5 is not a perfect square. So this one, we can't actually go any further, and we just have to kind of leave it like that. Let's look at our last one here. 18x cubed minus 50x. Again, this is possibly a difference of squares because it only has two terms. Again, we have to look to see if there's anything that we can factor out, common factor first. So there is definitely a 2 that we can factor out because 18 and 50 are both divisible by 2, and x is common to both terms. So if we factor out the 2x, we're left with 9x squared minus 25. Both of these things are in fact perfect squares. This would be like 3x squared, and this is 5 squared. So this is a difference of squares. Now remember, if you don't recognize the difference of squares, and you see something that has two terms, an x squared and then just a constant, you can always think about it maybe by putting in that middle term with a coefficient of 0. And then you can factor this using the AC method like we were doing before. But it's much quicker to just recognize this difference of squares pattern. So we'll still have the 2x out in front, and this part that was in the brackets is going to factor as 3x minus 5, 3x plus 5. We've got it written as something times something times something, okay? So we have got this in our factored form, and we are done.